So, we're continuing statistics. This time, within this little bit, you guys are going to be able to graph and interpret different information from cumulative frequency curves, okay? Now, we have already talked about frequency tables, all right, previously, okay? You guys should be getting down this goal, okay? Goal still applies because you have one big packet, all right? So with frequency tables, take this last example right here, okay? Whoa. I'll go back to that page. Right. How do you know which, what's the mode? How do you know the modal grade? How do you know that? The mode, that's the definition for mode, is the one that shows up most often. Based off of this table, because it's not like the data is all listed out, how do you know which one's the mode? What about the frequency? It is the grade with the largest frequency, which would be what? Which would be what? 4. It would be 4. Frequency, the highest one is 34, so the modal frequency is 4. The modal grade is 4. All right? The X is the topic, the concept that you're basically given in this data is that you're given all these grades. 1 shows up 1 time. 2 shows up 6 times. 3 shows up 19 times. Are you getting it? That's basically what it is. But instead of listing all of those things out like that, it's grouped nicely into a table. Okay? And you can use the table to figure that out. So this would be your mode. 4 would have been your mode. Now, how do you find the mean when you have a frequency table? How do you find the mean? Well, you would need to multiply. What things are you going to multiply? You're going to multiply the grade and the frequency, because basically what happens, instead of doing 2 plus 2 plus 2 plus 2 plus 2 plus 2, that's the same thing as doing 2 times 6, which is 12. Okay, so you multiply the grade by the number of times it shows up, and then what do? We're still looking for the mean.
You add them all up and divide them by however many, 7.
So you say not 7.
What?
You don't divide it by 7. Because technically, how many grades do you have?
That number, like
the total what? Total grade or total what?
Frequency.
And you divide it by the total frequency. That is how you figure out the mean. So you would multiply the grade and the frequency and add it up. And then you would divide by the total frequency, and then that's how you would find your mean. How would you find your median? I know it doesn't ask this in this particular question, but how would you find your median in a frequency table? What does median mean?
The middle number.
The middle. And so instead of listing out 1, 2, 2, 2, 2, 2, 2, 3, 19 times 4, 34 times 5, 32 times 6, 18 times and 7, 10 times, and then trying to go back and forth to cross out, there's another way you can do that. What's the other way?
Can you multiply them all together?
That's still taking up too much time.
Multiply them all together? No?
Oh, I was gonna say that too.
This formula, but it doesn't represent the number, it actually represents something else. It does represent a number, but what number is it? What does n represent? What does n represent? N represents your total frequency. Okay? That's what you would do. So first off, what is this? What is your total frequency? Add these numbers up right now. Add these numbers up right now. So, n is 120, so what you would do is you do 120 plus 1, divide that by 2, and then you'll get a number. What number is that? 60 what? 60.5. Now that 60.5 is not your median, okay? First off, we're talking about grades here, so we're looking for the median grade. But 60.5 basically tells you that is where the median grade is. It is the 60.5th number in this sequence of numbers if we were to list it out. That's where it occurs. Now, how do you do that with your frequency table? Well, let's see. 1, then you have 6 2s. How many numbers is that? That you have so far? You have 7. Then you got 19 3s. How many numbers is passed now? 26. Okay, everybody with me? So by the end of the 3s, if we were to list these out, we would be at the 26th number. Now we have our 4s. We have 34 4s. The last 4 is where? How many numbers down? 60. So everybody sees that? So out of all your numbers, 4 would be the 60th number in this whole list. Then the first 5 would be the 61st. Everyone with me? So what is the median? 4.5. Okay? That's how you go about that. Because heaven forbid, this was only, what, 120? Some of your problems are going to have like 200 things of data. And trying to do all that in your calculator is going to take forever. Listing it out, oh my goodness, will take forever. Okay? So you can find the mean, median, mode of a grouped frequency table using similar features that how you would to find the mean, median, mode for a frequency table. For group data, you can find, this time it's called a modal class, okay? So now you're not looking for one specific number that shows up the most, but you're looking for the class that has the largest frequency now, okay? So not the number that has the largest frequency, but the class that has the largest frequency. And you're going to have to find an estimate of the mean. With a grouped frequency table, okay, you do not know how many numbers are, like what are the numbers within that group, okay? So in order to find the mean, you have to actually find an estimate, okay? So to do that, of course, the modal class is the group or the class that shows up the most, okay? Just like how the mode before was the one that had the largest frequency. And then to find an estimate of the mean, same formula as it was before, except this time, x of I represents the midpoints of each class. And that's very important. These are the midpoints of each class. So again, to find the mean, what you're going to do is you're going to take each of the group's frequencies and multiply them by the midpoint of each class, and you'll add those up, okay? And then divide it by the total frequency. So take a look at this next example that we have, okay? I believe we have something talking about some times of a sumo wrestling match, okay? It asks you to find the modal class. That should be easy enough, right? You're looking for the class with the what? With the most? Most what? Most frequency, okay? So when we look at that, that should be pretty easy to see that the modal class is what? 20 to 40. So you literally just write down that class. That is your answer, okay? Easy points right there. Which one has the most, okay? Can't say total, okay? That actually represents the sum. Wait. Now we have to find an estimate of the mean. We won't be able to find the exact mean because we don't know exactly what the times were. We just know the range, okay? So we have to multiply the frequencies by their what? Their midpoints. And the midpoints they're referring to are the midpoints of your x value. So that's your time in this case. What's the midpoint of the first class? 10. If it's ever anything harder than that, you take the top number, add it to the bottom number, and divide by 2. That's how you find the midpoint. What's the next one?
30.
And the one after that?
50.
And the one after that?
70.
Keep going.
90. 110. 130. 150.
That's it. There you go. Okay? You have to find the midpoints. After that, the next column is just there to kind of make it nice and clean for you. But you take the midpoints and you multiply them by their frequencies. So what's 37 times 10?
370.
That's 370. What's 62 times 30?
1,860.
Can you guys do the rest of them?
Yes.
Okay. Check back in a second. Alright, let's see how you did. The third class, what was the product? 2,300? The next one. The next one. And the one after that. And the one after that. For a total of?
I got 9.
I got 9,640.
Yeah.
Jesus. So, your numerator is the total when you add up the frequencies times the midpoint. So that's your numerator, 9640. And then you divide it by your total frequency, which we see is, and when you divide, that gives you your mean of. So that was the mean time of these sumo wrestling matches. Okay? Questions on that?
So we don't gotta go back and check what 48 is.
This one actually found exactly what the mean time was. I think you're thinking median. If we want to find like the time in the middle. Now there is a way to do this on your calculator to check. Okay, so pull out your calculators. Pull out your calculators. Where do I go? Because I do need to access my list. Stat. I go to edit, and then up to L1 and clear. Do not press delete. Delete literally deletes the column, and you have to have L1 there. Does anybody not have L1 in their calculator? Okay, cool. All right, so now in L1, you want to type in your midpoints. You want to type in your midpoints, okay? So do that. Type in your midpoints.
That was quick. Just logged mine.
In L2, you're going to type in your frequencies, okay? You're going to type in your frequencies into L2, so type those in.
I lost L2.
Yeah, I don't have an L2.
Okay, if you lose any list, L1, L2, L3, L4, L5, this is what you do to get it back. You press the stat button. You go to option 5 that says set up editor, and you click enter.
Alright.
When you go back to the stat into your list, it'll be there.
Hello.
Okay, and when a list goes missing, that means that it got deleted. You don't want to delete a list, you want to clear it so you can type in new information. And make sure you clear it. Don't try to type over data because you don't know if there's more data underneath. And you always want to make sure that your dimensions are the same. If you have 8 things in L1, you want to make sure you have 8 things in L2. Nothing uneven, or else you're going to get an error message. Okay?
My life is there.
Now, what you want to do is you want to go to stats. Go over to cal just like before. But this is going to be a little bit different from the data where there was just, one thing, one piece of data. Okay? Just like your times or just like the number. We have 2 things we have to worry about here. Not only do we have your midpoints, but we also have your frequencies. So you're still going to go to 1 bar statistics. And I'll do it both ways. If your calculator looks like mine, if it doesn't. Okay? If your calculator does not look like mine, and it just pops up 1 bar statistics, what you'll have to do is you'll have to type the second button and then type the number 1 button.
Second one.
Like literally. Second button, 1 button.
It's L1.
And L1 will pop up on your screen, yes?
Yep.
Then you're going to hit the comma button. The comma button is right above
EE.
7. When you click it, a comma will now pop up. And then you'll do second button
L2.
and the 2 button. So then L2 will pop up. If you don't do this, then the calculator is going to figure out the mean and the median, all that stuff just for whatever's in L1. And it automatically defaults to L1. That's why it worked the first time, because we put everything in L1. But with 2 pieces of data, we have to let the calculator know, hey, we're taking into consideration that these midpoints show up this many times. Now when you click enter,
This is quick. Oh, no, I have
Does it say 48.2 for your first number?
No, it's
Okay,
it's
it should. So if yours looks like mine, you want to make sure your frequency list is in L2. It's L2. So you press second and the 2 button, click calculate, and it should be that number. So again, as you see, the X with the bar, that means mean is the same. So you can double check if you do it by hand, you can check it with the calculator, or vice versa. Okay? Questions?
Okay, on the IB test, do we tell them?
Do you tell them what?
I did this all.
No, the one thing they don't want to see is calculator gibberish on there. Do not do that, okay? There is a way to do it by hand, which is this right here. So showing that would suffice, you know, the midpoints and the frequencies, and then getting your answers that way, okay? It's very hard to show what you're doing in the calculator and trying to explain, okay? The one thing you can't do is you can't try to justify or reason something by saying, I plugged it into the calculator, okay? You can't do that. So there's always a literally by hand way to do everything, okay? I want you to do the next two examples. I'm going to give you guys about 5 minutes to do these. Let us know if you have any questions. All right, so those two you were to do on your own. It was pretty straightforward. This right here is an example of a what? A bar graph.
Frequency
A what? It's called a histogram, okay? It's basically a bar graph, but the difference is that the bars, they all touch each other. You guys had to graph a few, like one or two of these in the last lesson, okay? But this bar graph definitely, as well, is another way to interpret your information. The x-axis basically tell you your ranges, 10 to 20, 20 to 30, 30 to 40, and then the bars and their height tell you exactly how many students actually scored within those ranges. So there were 6 kids who scored between a 40 and a 50. So you should have took 6 and multiplied it by what number? 45 when you were doing your mean, okay? We're going to keep on going. We're going to talk about cumulative frequency curves, which is another way to represent data. You have your histograms, you have your tables. A cumulative frequency curve is another way to represent your data. And it is the sum of all the frequencies up to and including the new value. So basically, when you look at cumulative frequency curves and their respective tables, you're looking at the total, like you're adding the frequencies as you go. So it's not individual frequencies, but frequencies as you go. To draw a cumulative frequency curve, you are going to construct a table. That's the easiest way. You're going to find the upper boundaries of that table. Upper boundaries is something that you would have done on the very first day that we started statistics. How do you find the upper boundaries when you're looking at a table? Thank you. Flip back. If you do not remember, how do you find the upper boundaries?
It's like you have your thing and if you circle the first one and you go up one. You know what I'm saying? Like, yeah.
Like when you're looking at your frequency, like they're going to be listed, okay? As ranges. To find your upper boundary, you have to take the upper number
And then the one like that.
and then the bottom number and do what to those?
You add them and divide them.
Add them and divide by 2. You got to find the average. So you have to find the upper boundary of each class by doing that. So that's going to all go in one column. And then the corresponding cumulative frequencies go into the other. Okay, that's how you create the cumulative frequency table. After that, you would need to graph it. Your upper boundaries go on your x-axis, and then your cumulative frequencies go on your y-axis. So looking at this example, the supermarket is open 24 hours a day and has a free car park. The number of parked cars in each hour is monitored over a period of several days. The results are shown. We're going to create a cumulative frequency table and then graph this information. So, this is what you have here. Over several days, person monitored how many cars were in the lot over time. So there were 6 times when there were between 0 and 49 cars. There were 23 times that are between 50 and 99 cars, so on and so forth. We're going to graph this. Find the upper boundary of this very first class. 49.5. You take the upper boundary the lower boundary, and find the average. That's how you find the upper boundary. Okay? That's what you would have did back in day one. What's the next boundary? 99.5. Take 99, add to 100, divide by 2. What's the next one? 149.5. Will it always be something like this? No, it really depends on how the data is already arranged for you. What's the next one? 199.5. The next one.
249.5.
Keep going.
299.5. 399.5.
Now on this last one, if you continue to follow this, what would have been the lower boundary of the next class?
449.5. Oh wait, lower boundary.
This one. It would have been 400 to about 449. So to figure out that 399.5, you take 399 and 400. That's where that number came from. Okay? Cumulative frequency. You're adding them up. You're adding up your frequencies, okay? So what's the first frequency that we have? 6. Cumulative means we continuously add on to it. So if we start with 6, which is the very first frequency, the next frequency is 23. What would be the cumulative frequency here? 29. You get 29 because you add 6 and 23. And you continue. What is 29 plus 41?
670.
70. What's 70 plus 42? 112. Again, we're doing this because it's asking for a cumulative frequency. So we take the previous frequency and we add the next one. What's the next?
142.
The next one.
166.
And then we're going to add 166 to 9 to get
175.
And then we're going to add 5 to get
180.
180. So 180 basically represents the total frequency. So now that we have our table, these are going to be our x-axis, these are going to be our y's. And let me go ahead and stress this now, because I didn't get a chance to stress how much I did in 4th period. If you ever have to create a graph yourself, okay, it is very important that you label your x-axis and your y-axis, not just with what represents the x and y-axis, but the scale as well. How is your grader supposed to know what your scale is if you do not tell them?
They look at it and they have to figure it out.
No. Because after grading 100-something papers and they get to yours and yours has no scale, their patience is going to be but so big. So please do not give them any reason to deduct you because you decided not to label this. Okay? So our x-axis is going to represent our upper boundaries. Okay? And our upper boundaries were our cars, the number of cars that showed up in the hour. And our y-axis is going to be our what? Our cumulative frequency. Okay? And again, cumulative frequencies are used to basically gather different types of information about your data. So it's very important that when you create your own scale that is to the best scale that you can, evenly to represent your data. Now, this right here is 1 centimeter paper. Felt like I've talked about this before, but I'm just going to go ahead and go over it again. This is 1 centimeter paper, which means that every thicker line represents 1 centimeter. Now, a lot of times, it will say, make 1 centimeter represent 5 units or something like that. If it doesn't, then you should go ahead and automatically assume that 1 centimeter equals 1 unit, okay? You don't go 1, 2, 3, 4, 5 unless it tells you to do so, okay? That would be ridiculous, especially if you're trying to go from like 0 to 10. All this graph paper would just be limited down to this. Does that make sense? Okay? So if they give you a set graph paper like I have, clearly you can see that I've cut it, try to fit your data within that. So, if our upper boundaries are going to go on our x-axis, what would you say is a good scale to label each one of our centimeter marks?
49.5. No, each one goes up by each.
I see what you're saying. I would suggest 50, and the reason why is because, like I said, you use these curves to find other pieces of information. So if you split it like that, then that means that every other line in between has to be like a certain equal distance apart. So if we make it 50, then each one of these represents 10.
All right.
Okay? So let's go ahead and let's label that up. What should we make the y-axis?
It should go up by.
As include our highest cumulative frequency, we basically have 4 centimeters here.
Yeah, 50s.
If we go by 50s, then each one of these would be 10.
Yep.
And our highest frequency, our cumulative frequency would be 180, and so it would fit in that graph. So that's good. If you did do 180 and then try to divide it, like say by 4 or something, again, you're trying to figure out, okay, exactly what do each one of these little lines in between. Okay? Now from here, you just graph. We have 49.5 and 6. Okay? It's a curve. Cumulative frequency curve. So 49.5 is super close to 50, and it need to be at 6, which is a little bit below that first light gray line. Mine's light gray. Then I should be at 99.5 and 29. So 29, that's 10, 20. I'm a little bit below 30 and really close to 100. Then 149.5 and 70. So 70 is actually on the line, and then 149.5. Continue to graph the rest of this data, okay? Graph the rest of this data using that table. Everybody have their data in? Almost. All right, so our first data point was at 49.5 and 6, okay? But there's a potential that it could have had 0 cars, right? Okay? So actually it's going to start there at 0, 0. So then you draw a smooth curve to connect all these points, and you want to make sure that it's a smooth curve, because like I said, you use this curve to try to determine different pieces of information. And so you want to be as smooth as possible, because it will say, using your graph or determine, X whatever. So it's important that you use a graph that's a good drawing. Questions on drawing cumulative frequency curves?
Would you have to label that with a title?
No. Now for your IA, yes. If you for whatever reason like cumulative frequency curve in your IA, yes, give that a title. But not for these.
Wait, don't we have first name?
Yeah.
You said put a scale. I thought you had like scale is.
Oh no.
Okay.
Like label this. That's
Okay.
label that part.
Okay.
Okay. Now interpreting your cumulative frequency graphs, okay? You can estimate percentiles and quartiles with cumulative frequency curves. Percentile sounds like what word? Percent. Okay, so percentile separate your data into hundredths.
Isn't this the plot in this scale?
We're getting that. Not yet. Quartiles separate your data into 4 quarters. 4. Okay. You have a lower quartile, you have an upper quartile, and you have a median. Lower quartile is in the 25th percentile, the median is in the 50th percentile, and then the upper quartile is in the 75th percentile. So when you take like the SAT or the ACT, and it talks about, you get your score back and it talks about you're in like the 75th percentile, that basically means that you did better than 75% of the kids who took that same test. Okay? That's what that means. If they say, the 80th percentile, then you did better than 80% of the people who took that particular test. Okay?
What if I was just one?
Depends on what college you want to go to. All right. So to find these pieces of data, the lower quartile, which sometimes can be denoted as Q sub 1, is the value on the curve that corresponds to n plus 1 divided by 4 on your cumulative frequency axis. N represents your total frequency, just like it did before, okay? So you can use your cumulative frequency curve. You figure out what your total frequency is, add 1, divide by 4. That number tells you where to look on your y-axis to find exactly where the lower quartile is. So on whatever your curve is, and whatever your total frequency is, you'll plug that in. You'll get a number. You'll see where it corresponds on your y-axis. And wherever it hits your curve, this value is the value that represents your lower quartile. Okay? That's how you use that formula. It doesn't tell you exactly what the lower quartile is, it just tells you where to find it on your curve.
So you would put this number into
So like say, take your last example for example, right? This one here. What was our total frequency for this problem? What was our total frequency? It was also the last point that we plotted. 180. Okay? It's always the last point that you plot. It's 180. So you take 180, add 1, and then divide by 4. What's 181 divided by 4? Somebody do that real quick. 45.25?
Yeah.
So this does not tell you what your lower quartile is. It just tells you where to find it on your curve. So basically what you would do is you would go along your cumulative frequency axis and find where 45.25 is. So it's probably somewhere halfway between 40 and 50, right? That's why it's important. Your scale is pretty neat. Then what you do is you draw a horizontal line over to see exactly where that hits your curve. Okay?
About 120.
And then you drop down a perpendicular to see that, hey, my lower quartile is about 120, this is talking about cars, 120 cars, okay? So that basically means that 25% of our data was smaller than 120, okay? That is our lower quartile. Does everybody understand that? Okay, now, this is going to be also part of your notes, so you guys should do this too on your graph because it says underneath where all this stuff is, where you're writing the notes. Do this for the last example. Okay? You definitely want to make sure you write that in. The next one is your median. Okay? Your median is the value that corresponds on your curve to the n plus 1 divided by 2. Same thing as it was before. On your cumulative frequency axis. So take that last example. Let's find the median of it. What is the total frequency? So we do 180 plus 1 divided by 2. What number is that? That's not our median. That just tells us where on our cumulative frequency axis the median is located. So I'm going to go back to my picture. I'm going to go to 90.5, which is really close to 90. Okay? Draw that horizontal line over. Kind of wavy, but you get my curve. Hits my curve and drop down a perpendicular. Based off of my graph, I could possibly say that's about 170. Now, this is where a lot of students have, this is where the argument comes in about, well, I was close enough, it's based off of my graph, but you got to understand, on the mark scheme, they give me a computerized cumulative frequency curve. So it's probably the most exact that it's going to possibly be. They're going to tell me what the answer is, and then on the side, it's going to say give or take 1 unit, 2 units, 3 units. It really is dependent on what the scale is of that graph. So for my curve, I can say it's about 170. On yours, you might say it's like 168, 165 maybe even, okay? But depending on how spread out your data is, they might say give or take 5 units, this is pretty spread out. Within 1 centimeter, I'm going 50 units. Okay? So it might give me 5 points on both sides. But if it's small, say this goes from like 0 to 10, then it might be small. Okay? So don't just be like, oh, I'm just gonna round up. It might actually be 165. And they might only give or take 3 units. So be careful. Okay?
What would you put, 168?
For me, I'll probably put, to be honest, I'll put 170 because the curve I did for here was a lot better than this one. I was kind of lucky on this one. I'll put 170. My first curve was better.
Do you think they would have took 168?
I had to go back and look at the marking for this particular one. Okay? Questions on the median? The upper quartile, which is labeled as Q sub 3, similar to the first quartile, but it is the 75th percentile. It's 3/4 of your data, so it's 3 times n plus 1 divided by 4. Okay? Same example. We already know our cumulative frequency was 180. Somebody tell me what number that is. Is this Q3? No. It tells us where to look. So I'm looking at 135. So I got 100, 110, 120, 130. So 135 is halfway through. It's about here.
About 250.
No. On my particular curve, mine hits at about 230.
Yeah, mine hits on 250.
Okay? You want to make sure that it's a smooth curve, as smooth as possible. Okay?
Oh, a little high.
Now, when they give you a cumulative frequency curve, like one that's already computerized, then that scale, give or take, is going to be really, really small. Okay? They're expecting you guys to be spot on. Questions on finding the data so far? Percentiles. Say I want you to find the 80th percentile, the 40th percentile. It's P n plus 1 divided by 100. Okay? They'll give you what percentile they want you to find, or they might say, this particular number is what percentile. Then you set it up like an equation. Okay? There's an example that we'll do together where we'll do the percentile. Okay? And the last one is IQR. IQR stands for interquartile range. This is where a majority of your data lies. And they lie between the upper quartile and the lower quartile. So to figure out that range, you just subtract those two numbers from each other. So for my last example, my upper quartile was 230. My lower quartile was 120. So then my interquartile range would be 110. I'll just subtract them. Simple as that. Okay? All right, so flip over. We're going to use this example here. And this one, I know some of you guys will probably be able to see exactly where the arrows are. But I had to pull out the graph from the actual key to get it. Okay, but I just want to kind of go over with you again. Looking at this graph, and if this up here is definitely not the best graph. You have a better one on your paper. What is the total cumulative frequency? What is the total cumulative frequency? Look at the scale.
120.
It's 120. Okay? If you look at the scale, 2 centimeters separates 100 and 150. So this one right here would have to be 125, meaning that each one of these little ones in between would have to be 5 units. So n is going to be median. That's 120 plus 1 divided by 2. That's the formula. What number is that? That is not your median. That tells you where you need to go look. Since this is divided into 5s, 50, 55, 60, 60.5 is basically right there. You see where it hits the curve, drop down the perpendicular, and what say you? 35? Based on my extremely pixelated graph, that looks like it's about in the middle. 35. Questions? The interquartile range. What's the formula? For the interquartile range, what's the formula? So you actually have to figure out what those are. What is Q3? What is Q1? Subtract them from each other. Okay? The formula for Q3 is 3 times n plus 1 divided by 4. N is 120. What is that number? $90.75. So you have to figure out where is that number, or what number does that correspond to in the graph. So 90 is about right here, so we're going by 5s. Hits the graph. Drop it down. What number is that about?
46.
46. Find Q1. Everybody find Q1. What's 121 divided by 4?
30.25. I did 27. No? Wait. Yeah, I got 27. Just 27. Our graph is off. Well, that graph is off.
So mine's about, I'll say mine's about 26. You can say yours is 27. But whatever you get, you take the upper quartile and the lower quartile and you subtract them to get your IQR. Mine would be 20. Whatever you said your Q3 was and your Q1 was, you subtract those and get your IQR. This is definitely where a follow-through comes in, okay? Because whatever your Q3 and Q1 are, whatever yours are, you subtract them and get your IQR. Okay? Last one, it says the 70th percentile. Find the 70th percentile. That's the formula P n plus 1 divided by 100. N is 120 still. What number is that?
70 plus 1. 84.7.
84.7. That is not your number. That is where you can find it. So you go to 84.7. Okay? So that's 60, 65, 70, 75, 80, 85. So I'm a little bit below 85. So to be in the 70th percentile, you would have, and let's just pretend like these are scores, okay? This one's not labeled, this is labeled X. Let's say these were scores. To be in the 70th percentile, you would have need to have scored about I would say a 73. Sorry, a 43. To be in the 70th percentile. Do you see how you go about finding data? Using a cumulative frequency curve? Are there any questions? Okay? doing the examples through page 20 in your notes for homework. And what I would like you to do before you leave, I want you to do the problem that's on page
19.
on page 18. Mm-hmm.